Okay, so we're asked here to find the volume of the triple using the triple integral. So this will give us a volume because the function here is 1, bounded by the planes x equals 0, y equals 0, z equals 0, and 2x plus y plus z equals to 2. So first thing we've got to do is sketch it. Okay, so that's my y-axis, z, and x. So next thing we need to do is to find our x, y, and z intercepts of the plane. So to find the x-intercept, we let y and z equal to 0. So we have 2x equal to 2, so x is equal to 1. So intercepts at x equals 1. Y-intercept, let x and z equal to 0, so y is equal to 2. So it's intercepts over here. And similarly, to get the z-intercept, you let x and y equal 0, so we have z is equal to 2. So it intercepts over here. So my plane will be plane in the positive octant of the xyz axis, so that's where x is greater than 0, y is greater than 0, and z is greater than 0, will be this triangular pyramid. Okay, where that's the floor, that's the back wall, that's the side wall, and the plane itself is the front wall. Okay, so we need to find the volume. That's the base, that's the length, and that's the height. Okay, so one thing to bear in mind with the volume of a pyramid, so volume of a triangular pyramid, I should say, volume of a triangular pyramid is equal to a sixth times base times height times length. So in this case, it's equal to 1 times 2 times 2, which is 4, divided by 6, which is 2/3 units cubed. Okay, so that's the volume of a triangular pyramid. We're asked to find it using integration, but we'll use that answer to make sure we've got the correct answer over here. Okay, so let's do it via the integral. So the first thing we need is to define this volume V and get our limits for x, y, and z. Okay, so when we have a triangular pyramid like this, we generally let one of the variables have the constant limits, and we usually choose x. So x is clearly between, x is clearly between 0 and 1. Okay, so x has all the values between 0 and 1. To get the y limits though, it's actually bounded, it's not between 0 and 2 as most people think. The y limit is bounded from the line y equals 0 to this line y equals some function of x. So that's a straight line on the xy plane. So to get that equation of the line, we come over here to the equation of this plane, and we let z equal to 0. So we have 2x plus y is equal to 2. So the equation of that straight line is going to be y equal to 2 minus 2x. And that's the upper bound on y. So the lower bound is 0, and the upper bound is that straight line, 2 minus 2x. Similarly for z, the bounds on z, if we're coming up from the negative z direction through the plane, up, and we hit the surface over here. Okay, so the lower bound is the floor here, which is the plane z equal to 0, so z is greater than 0, but less than the plane itself. And to get the equation, well, we're given it here, we just have to rewrite that in terms of z. So it's 2 minus 2x minus y. Okay, so we now have our order of integration, because z has limits that depend on x and y has limits that depend on x, and x has constant limits. So it's going to be x first between 0 and 1, y second between 0 and 2 minus 2x, and z first between 0 and 2 minus 2x minus y, dz, dy, dx, and the function we're integrating is 1. Okay, so it's going to be between 1 and 0, 2 minus 2x and 0, and once we integrate, it becomes z, and we're going from z equals 2 minus 2x minus y, and z equals 0, dy dx, which is equal to 0 to 1, 2 minus 2x from 0, Sub in that for z, we have 2 minus 2x minus y, and sub in z equals 0, we just have 0. So that's dy dx. Okay, so equal to 0 to 1. Now we just need to integrate this with respect to y. So I get 2y minus 2xy minus y squared on 2, and we're subbing in 2 minus 2x and 0. So we're subbing y equals to 2 minus 2x and y equal to 0. It's important to write y there so we know which variable we're subbing into. Okay, otherwise we increase our chance of making an error, which we want to avoid. So 2 times this function, so I get 4 minus 4x. Then I have minus 2x times this function, so I have minus 4x minus 2x times minus 2x is plus 4x squared. Then I have minus a half of that function squared. And when I sub in 0, I get 0 from everything. So dx. So it's equal to 1 to 0. So 4 minus 8x plus 4x squared minus a half times, we've got to expand that, so that becomes 4 minus 8x plus 4x squared dx. So it's equal to, between 1 and 0, 4 minus a half of 4, so that becomes 2, negative 8x plus a half of 8x. Okay, so that's minus 4x. And 4x squared minus a half of 4x squared is 2x squared dx. So we just need to finish this off by integrating this with respect to x. So it becomes 2x minus 2x squared plus 2 on 3 x cubed, x equals 0, x equals 1. Oop, got that the wrong way around. X equals 1, x equals 0, equal to 2 minus 2 plus 2 thirds. And when I sub in 0, I just get 0. 2's cancelled to give me 2 thirds. Alright, so the volume of this triangular pyramid, or the volume bounded by these planes, is equal to 2 thirds. Okay, and we can verify that. We had over here 2 thirds, 6 times the base times height times the length. So we verified our answer.